going to say that a solution is at equilibrium. Okay? And most of the time, equilibrium reactions are actually reversible. They go back and forth. Got it, folks? Excellent. So now one law which we didn't cover under the class law, but should have, but it's in chapter 6 for a reason, because it's about solubility of gases, you see? So we did cover that in chapter 5. It's called Henry's law. And it's a really important law because that's what very useful use every day as it makes the best proportion of solid and outside exterior drink. Okay? So Henry's law says that gases, the solubility of the gas, is directly proportional to the pressure of the gas. Solid. Okay, so think about it. If you had so let's say you have a bottle of Coke, right? Let's say you have a bottle of Coke. And so here is a container of Coke. So basically what Henry's law is saying is that if you have gas molecules over here, and this is the level of the Coke in it, let's just say, the law says that how much pressure the gas molecules apply on the surface, the pressure that they apply, that's going to decide on soluble liquidity. It makes sense. But if you're a high pressure, the gas is going to be forced to stay in. You just have a single bottle, the gas will stay still there. So you're going to force the gas to stay in by applying what? By applying pressure. That's it. That's what we call. But what else is the minute you get to the local law? The local pressure is gone, which means you're going to sorry, so basically that's what it's saying. As the pressure increases, you're likely to have more stuff to solve, okay? Okay, so you need to know it if you see it in a true or false statement or following define Henry's law. Expect kind of question. Next on concentration. Now we start the math. Concentration. So remember in chemistry, there is no such thing as math because chemistry is a mathematical subject. So what we're now going to do is define concentration. And we define it in many ways. For you nurses, budding nurses I should say, there will be percent solutions. Like 3%, 10%, 75%, 70%. How do they make those? Do you ever know how to make those? They can have a sterile condition, so they use water that's pretty sterile, and they pack up in that, they dissolve it in water and add water, right? But you know how they make it. That's what we're going to do now, is learn how to make those concentrations. Okay? And why are we learning this? Because concentration affects a lot of things. It affects melting point, it affects solubility, it affects a lot of things. So that's why we need to know how to make these solutions. We start with the first thing, weight by volume percent. Weight by volume means M over V, mass over volume. Okay? And you see how it's given? Percent mass over volume. So if I say, so now you need to know what a solute is and a solvent is, and I'm going to use those words, solute and solvent. Yes? How many people are solute? Who remembers? Exactly. Present to a lesser extent. That's going to be solute, the amount of solution. So concentration is the amount of solute, which is amount as in grams. Because M is given in what? Grams of solute divided by volume is often given in what? Milliliters, right? Of solution. And because it's a percent, what do you need to do? Times 100. Did everybody get this, please? So that's the plus formula for this graph. Grams of solute divided by milliliters of solution times 100. All right. So let's look at the first problem, shall we? Calculate the percent composition of the percent composition, which means percent mass over volume, of 2.00 times 10 to the 2 milliliters containing 90 grams of sodium chloride. So let's use it. percent energy, right? What's given? Mass of the solute, is it given? What's the solute here? 20 grams of sodium chloride. Is the volume of the solution given? Yes, in milliliters, right? All you have to do is substitute those numbers. So the percent mass over volume is going to be 20.0 grams, right, solute. And that is division line, folks, divided by 2.00 times 10 to the 2 ml. Yes? And don't forget what? Times 100. Yes? So once you get 10.0% M over V. Can you all do another problem if I gave on something like this? If you have the formula in front of you? Okay, let's see if you can. Another problem here. And remember, I'm not always going to ask you for percent M over V. What if I ask you for the grams of solute? Look at this. Calculate the number of grams of glucose in 7.50 times 10 to the 2 ml of a 15% solution. What's given? Okay, the volume is given. I agree. What else? The final percentage, which is the percent M over V, is given, yes? So what are we trying to find? The grams of glucose, yes? Shall we do this problem together? Okay, let's begin. Write those numbers down for me, please. 7.50 times 10 to the 2 ml is the volume of solution. 15.0% is the final percentage. Okay, so here's the volume. Here's the formula. Percent M over V is equal to, yes? Shall we begin? Is equal to grams of solute divided by volume, or I should say volume in ml, of what? Solution. And I'm abbreviating because I don't have room to write everything, okay? And let's not forget, times what? Times 100. Correct? Now, my question is, what given? Is this given to you already, the final percentage? Okay. Is this given to you, the volume of the solution? Okay. Okay, well, okay, it's writing with my finger. God. So 15% is given. Yes? Is given, and what you're trying to find, folks, is the grams of solute, X. And you're going to divide that by what was that given to you? The volume? 7.50 times 10 to the 2 ml. Do you remember that, folks? Times 100. Yes? Now the question is, how are you going to solve for it? Yes? That's the question. How are you going to do it? Try it. 50% times 7.55. Yeah, I'll teach you a trick, right? 7.50, correct? Okay, I'll teach you a trick here. Before you even continue, do you see the 10 to the 2 at the bottom here and the 100 over here? You see the 10 to the 2 and the 100? They cancel. Cancel it. Give yourself that stuff to do before you rearrange. Does that make sense to you all, please? So cancel the 100 with the 10 to the 2. So what's X then? Cross multiply. What's X? 15.0 times 7.50 is X. Does that make sense to you all? And so what is the final answer? What did you get, Corey? 100? 100 into how? 100.5 grams, is that what you all got? 12.5, sorry. And here also now. Very good. Right, exactly. When you say percent, and you already have written 100 over there, you don't have to show this time. Okay? You can do that. You can do that. If you decide to put this as 0.15, then don't show the 100. Then don't show the 100. Yeah. So it's the same thing, right? 15 divided by 100 is 0.15. Then you don't show the 100 of it. All right, very good. Moving on, let us do some problems before we move on from the book, shall we? Okay, excellent. Let's all turn to. I would like you all to turn to page 'Oh, good Lord, there is it. Okay, let's all try now. Calculate. All right, very good. Page 199. I'd like us to do, let's see. I'd like you to do B and D. B as in boy and D as in dog. B and D. Yeah, I'm on page 199. Page 199, problems B and D. She does. Is the stylus on the better, folks? Mm-hmm. Georgia, did you access the recording? Because you were absent, right? Go home and do it. That's okay. Yeah, no. I know. Yeah. So I don't want you to fall behind even if you miss a class, because this can help. And all of us have children and things, and life gets away. So just make sure you access these and stay abreast. That's okay. You'll remember it now. Okay, folks. When is the test? When is your next exam? Very good. That's a Wednesday, right? So we may not announce it all the time, but your next exam is coming up on November 4th, which is Wednesday, 2 weeks from today. Perfect timing for your class. By the way, next Wednesday is a holiday. So that's the day for you to be studying. You're very lucky to get this day off and go to class. Right? So don't You know, if you're free from school, use that time to study and ace your next exam. I believe, sir. I'm not too sure, but the next Wednesday. 28. I think it's 28 or 29, one of those. 28, I think. Yeah, 28. Right. I know. It was all over CNN. Back to the Future was yesterday, right? So today. I know. Whatever. We're not where they said we would be. I know. I know, me too. Okay, so tell me what you get for B. Did you open it? B? He towards the solution containing 15.0 grams. So you start off with percentage M over B. Always like the formula. Remind you of what you need to do, right? So you have grams of solute divided by what? Milliliters of solution times 100. So for those who just went right ahead and put over that number, 0.200 liters, what did you do? You subtracted that number. And do that because look what the formula says, right? So you should have done 0.200 liters because what you should have done. This is like you you should have got 15.0 grams, okay, so you want to get, divided by how many milliliters of that? 200, but I think we have 3 sig figs in the 0.200. I'm going to write it as this, 2.00 times 10 to the 2. How many people write it like that? What are they doing when you write it to the presentation? No. My question is, you could have written 200. Well, why did I write it like this and not write 200?
Big number.
What? Coming close. So, what is different between 200 written like that and 2.0 written like that? 6 people. That's the only reason you're right. Because once you get down, there are 3 significant measurements you're not going to get. And then don't forget what? Times 100. Now, what you should do right after that is run the complication right, is 10 with the 10 to the 2. Yes? I'm not going to bother to hear it. You know how troublesome it is to do something. So I'm going to just let this be, okay? It takes 5 minutes to do all that. All right, guys. So the final answer is what? Okay, so there's 15.0 on the top and 2.00 at the bottom. Please proceed. You should have 56. Thank you. 5, 0. What are the units? No. Yes. Over me. Any questions? Good. Now attempt the next one. Attempt the next one that I assigned, D. Correct? You can look at it, John. I'll come around. Yes, sir. Yes, sir. That's exactly why. Because Aaron, you understood the meaning of the word solution. Okay, so the second I assigned D intentionally to see if you understand the meaning of the word. Okay, how many of you finished taking quiz 4? Is it still open? Okay, in quiz 4, it was a dance with words. Did you see that? All of that vocabulary on that quiz. If you got them wrong, it's because you didn't quite understand the difference between atoms, molecules, moles, and AMU. Atomic mass units versus grams, or formula mass versus molar mass. They're not all the same thing. And so, vocabulary is critical. So in this problem D, if you look at it, it says, it's a good problem. 50 grams. And by the way, solution doesn't mean you always have to have what? Beautiful, and then 50 grams of arnica is diluted with 80 grams of helium in a 476 liter container, standard temperature, and all that good stuff. Calculate the percent mass overflow. How are you going to do that problem? Oh, Aaron, I'm sorry, my apologies. It says percent mass per volume of just argon, doesn't it? Just argon. Okay. So if you don't, you're not adding anything. You're not adding things. If it's just argon, then what is your solute? Argon. That's the thing that's going on the top. I'm sure you all are wondering, what am I doing about the volume? Are you, or maybe I'm assuming that? Are you remembering? Why not, sir? Why not?
Why not?
Well, John's asking me if he should use that number, right? He actually didn't ask me that. He is saying he thinks the volume should be just 76 liters. Do you agree? Well, yes, but should you use that number at all? Well, the question is, folks, if you have a container and if you have argon and what's the other gas? Helium. The whole point of what gases do is they fill up the whole container. So you have to do what? The volume that you should use is what? The volume of the container, except you need to add it in milliliters. So in a previous class that I taught, students are trying to assume that you use 50 plus 80, which is the two gases, right? The solution. Yes, but the problem is they're asking for volume, and those two are in what units? What units are those two? Argon and helium. Grams. I want grams over milliliters. I don't want grams over grams. You see what I mean? So, and because not the first time. So, you need to use volume. And the only volume I see here is the volume of the entire container. I don't know. All I know is that I have to use the total volume of the solution. The solution is conditional, right? Yeah, all of it. Exactly. Because go back to the formula, everybody. It doesn't say mass of solute divided by the volume of the solute. It doesn't say mass of the solute divided by the volume of the formula. What does it say, everybody? Volume of solution. Thank you. Meaning the mixture. Yeah. So I'm doing problem D now. Tell me how to do it. What's given? Okay, 50 milligrams, not milligrams, you mean grams. Sorry. 50.0 grams of argon divided by what? And again, that's too big. I want you to. No, 476 liters would be 4.76 times.
But then you can cancel out the.
Yes, you can cancel out the 100 from the 5. leaving a remainder of what at the bottom? No, there's a 10 to the 2 at the bottom. 100 is 10 to the 2 and 10 to the 5, so you have a remainder of 3 at the bottom. And you get what? What's the final answer? 50 divided by 4.76 times 10 to the 3. It's going to be a small number. It's going to be a really small number. Yeah. Give it to me in 3. Yeah, okay. 0.0105. Yes? It's going to be a really small number. Does that make sense? 0.0105%. Yes or no? Georgette, are you worried? What's the problem? You didn't get it?
Oh, no, I
Yeah. 15 points. Okay. Got it? Shall we move on? Any questions, anybody? Okay, very good. Oh, wait. I need to go to another slide. Okay, next one. What if I don't have a solution that makes it good? What if I solve it? You will grams of solution divided by grams of solution. Okay? You typically do these to solve the picture. Grams of solution divided by grams of solution times, again, same thing, times 100. You still have to times it by 100. Does that make sense, please? So what if you, did I give you the example for gold ring last class? Gold, how they make gold jewelry with copper mixed in it. You're not going to have milliliters, they're both solids, right? Copper is a solid, gold is a solid. Then how am I going to do the math? Well, you take the mass of one of those solutes divided by the mass of both metal states. That's the mixture. You see what I mean? Or look at the problem that's on the board. Calculate the percent mass over mass of platinum. And gold. More gold than obviously you can take it out from gold is gold jewelry. Right? And 14 grams of gold and 4.5000 grams of platinum. Okay? So the actual amount of platinum has a percentage because of the jewelry. And the jewelry is an item in this jewelry. It has an alternative. So you start off with solute on top. So 4.5000 grams. Moving on the top, right? You would divide it by not just gold, but the mixture. You see why? 4.500 plus 14.00 gold. Yes, because it's a mechanical solution, right? Any kind of moving by 100. Does that make sense? Okay. This is a problem for you based on this. Here's the next page. Example 6.2. Practice problem 6.2. Practice problem 6.3. Mass over mass of oxygen concentration contains 20 grams of oxygen and 80 grams of nitrogen. Right? Practice problem 6.2. about A first? What page is it? Did you get it? Yes? So you say percent mass over mass is equal to, what is the grams of the solute in this problem? No, what is your solute in this problem? Oxygen, right? So what goes on the top? 20. Okay. And what goes on the bottom? Yes, 20 plus 80. 100 grams, and you have to times that by 100, yes? So, you notice the 100 will cancel with the other 100, right? What is the final percentage? Grams cancel with grams, don't they? 20%. Did everybody get that, please? No, but the grams cancel. 20%. Easy. Try the pencil. The next problem says, calculate the percent mass over mass of argon in a mixture containing 50 grams of argon and 80 grams of helium gas. Yeah? All right. So once again, easy enough, right? You would say. So percentage would be equal to 50. Is that 50? You would say 50.0 grams of argon divided by what's 50 plus 80? Yes, 130 grams of mixture. Don't forget to times. Oh my God. Times 100. And this is going to equal what? Good. 38.5%. Easy enough, would you say? Very good. Yeah. because the units cancel, right? Okay, so 38.5%. Got it? Now what I want you to do is I'm going to switch gears and go back to practice. Let's see if you can do it. Practice problem 6.2b. Practice problem 6.2b. Practice problem 6.2b. All right. Calculate the volume of a 25% mass by volume solution containing 10 grams of sodium chloride. Yes? How did y'all do it? Okay. Yeah, the final volume is given as 25%, correct? And that is equal to, what are we trying to find? The volume. So what's the mass of the solid on the top? 10? 10.0? So 10.0 grams divided by X. Times, don't forget, times 100, yes? So, it seems to me that you need to do cross multiply. You take the X to this side, and you take the 25 to the other side, right? So you'd end up with 10.0 grams times 100 divided by 25. Yes or no? Is that big? Yes, X is in milliliters though. Yes. And I think I should write that. X in milliliters. Yes? That's what we're trying to find X. Correct? Okay, so now what did you get? No, it won't be 40 grams. Because 25 is pounds per ml, right? And the grams canceled with the grams, so grams has 40 ml. Does that make sense to everybody, please? Good. All right, now let's move on to the next thing. Last thing is, not last, but parts per thousand. You know, sometimes in environmental chemistry or in pollution aspects, they don't report concentration in grams and because they're so small quantities. So we define what we call parts per million or parts per thousand because it's so dilute, right? So percentage cannot be used all the time because percentage may be too big a number. Parts per million simply means instead of multiplying by 100, you will multiply by a. If it's parts per thousand, you'd multiply by 1,000. If it's parts per million, you'd multiply by a million. Yes? And that's all it is. So you see, grams per solute, look at this formula. Grams per solute divided by grams of solution times 10 to the 3 is parts per T, parts PPT, parts per thousand, yes? And if it is grams of solute divided by grams of solution times 10 to the 6, you won't say parts. So that's the only difference. Six 6.4, page 202. Let's do A. 6.4, page 202. Yeah, 6.4, page 202. Lead, yes. Calculate the of oxygen gas in a mixture containing 20 grams of oxygen gas and 80 grams of nitrogen gas. So what's the formula for parts per thousand, everybody? Parts per thousand, oops, excuse me. I shouldn't have written percentage. What am I doing? So its PPT is equal to grams of solute, yes, divided by grams of mixture times parts per thousand times what? Yes, times 10 to the 3. So then you plug in those numbers. What was the solute in your problem? 20 grams of oxygen? So be 20.0 grams of oxygen divided by, what is the atom? What's the mixture? 100. 0 grams of solution times 10 to the 3, correct? And if I were you, I just cancel the 10 to the 2 and then have to pay over. Right? So 100 at the bottom, cancel that to the 3 and you will do it. Yeah, there is a decimal over there. Yes? Yep. And so what's the final answer? 200 plus 2.00 times 10 to the what? To the 2. Any doubts? Good. So these are very straightforward problems, would you say? Okay, so let's move on to the next. Now let me come back to the moles, your favorite topic, moles. So we were looking at percentages, we were looking at all these percent mass over volume, percent mass over mass, but ultimately, a lot depends on the moles, right? So we have one more formula. Moles of the solvent, moles of the solute and volume of the solvent. So the next formula is molarity. Molarity is given by not grams now, moles. Look at the formula. Moles of molarity, it is given by grams capital M. Oh, I'm sorry. Did we just move on quickly? Sorry. Let's finish off the PPM. Okay, so how would you do the PPM in the same problem? PPM would have been, give me the numbers, please. Also the same numbers, right? 20.0 grams divided by 100 grams times 10 to the 6 now. Yes? So once again, cancel the 2 here, and you have a carryover of 4. Do you agree? I cancel. And that should give you 2.00 times 10 to the 4 ppm. Yes, sir. 2.00 times. All right. My battery's dying. So that's okay, because we have a few more slides to do, and then I can. You don't have to record every word, but that's easy. So if you're given the okay, so now with molarity, okay? Begin. Calculate the molarity of 2 liters of a solution containing 5 moles of sodium hydroxide. This is a truly warm-up problem. You're not going to get problem this easy. Okay? So basically, the substitute moles on the top, 5 moles of the solute, divided by what? The solution, no times 100 and all that. And the units are going to be what? Moles divided by liters. So the molarity has the units moles divided by liters. So this one is the same thing. Problem 6.6. Okay, practice problem 6.6 says calculate the molarity of KCl when 2.33 grams of KCl are dissolved in 2.50 times 10 to the 3 milliliters of solution. Did you all finish it? Okay. So remember, what's the formula? Molarity is equal to what? What's the moles of what? Solute, yes. Divided by volume in liters, not milliliters. So if you have 2.33 grams of KCl, can I just put that in here? Well, you should first be converting into moles. Okay? So you should be doing 2.33 grams of KCl, and you should have done grams of KCl is 1 mole. How many grams of KCl is 1 mole? 74 point? And you should be first doing that. Yes? So, did you do it already? What? So you would have had molarity equals moles divided by volume in liters. Yes? So this needs to be in liters. If you don't write in liters, so okay, sorry, it's only 2.5 kilograms into the 2 milliliters, and we're looking at so, let's substitute molarity. 0.100 equals to X, we're 0.25 liters. Here's what you pulled in. So that's it. Cross multiply, right? Cross multiply, right? So 0.100. I'm going to write out molarity as molarity over liter times 0.250 liters. Yes? And hold it off on the big end. Because I'm looking to keep it at L because it doesn't do it full way. I wrote out it in as moles per liter. Yes? Now I'm going to do it over liter. Yes? And you should make it up as 0.100 times point, I know that's a point here, point 250 multiplied with you get X equals what? 0.02 what? Now. Seems to me that you start with what's given, 0.25 moles, and then you figure out 1 mole of sodium chloride weighs how many grams? 58 points? Yes? And now you're going to end with a final answer of what? Does this make sense to everyone, please? Good. And that's how you expect it to do these problems. Any questions, please? See? And you're getting recorded. Yes, I did. Okay. I'm sorry. I just between when you put anything on timing.
Okay.
It's not like
Yeah.
So that's yeah. Molarity doesn't have to move. 7 doesn't have to change, right? It's just 11. Yeah. Thank you, Prakash. Okay. Any questions? What is the final answer? How many grams is it? 1.46 grams. Perfect. I just put it up, and that's your answer. Yes? Very good. So on the test, watch and what is the question asking? Is it asking for moles? What is it that I need to do, right, to be able to do the proper? Ready? So let's move on to dilution. Dilution is when you have to. Okay, what is dilution to you? What is dilution to you? Dilution is more concentrated, additional fat concentrated. Because the dilution ratio has solution of something, and that's what it is, because or they say made from concentrate. When they say oranges made from concentrate, so they're saying that it's given just to do oranges added or graduate. Exactly. Exactly. But here's the key thing to remember. The key thing to remember is do you change the number of moles? That is the key. So if you put the spheres in here to the number in here, they are the same. What's the difference? Yes. So if you put a bit of this, you may end up with a more concentrated because there are more moles in it. Versus if you took a mill of this, it would be less moles and less concentrated. So that doesn't mean that you choose like moles. So once you say why you can use this formula. Okay, so I want to also see them. Okay? So if you have M1 is equal to moles 1 divided by volume 1, what is moles 1 equal to? That is moles 1. The first beaker. Okay? The first beaker has 1, 2, 3, 4, 5 moles. Yes? Okay? So this is beaker number 1. And we're going to say that moles 1 is equal to, rearrange the formula for me. What is moles 1 equal to? That's M1 times this is great. Also the side is equal to the other side, yes? And so they need to so we get M1 times V1. Is that making sense? Now we have this much water in here. Let's say we take the same container, right? We still have the 5 moles. But now what did we do? We added water to here. We diluted it. Yes. So what is moles 2 equal to then? Based on the same formula, moles 2 should be? And moles 1 times V1, moles 2 would be M2 times V2. This is the second beaker, right? But do you agree that it's 1, 2, 3, 4, 5 here? And it's 5 over there. So would you say that the number of moles is equal in both? Yeah. So if moles 1 is equal to moles 2, then it must follow that I'm not even have equal M2 and V2. Okay? So you make all 3 use this relationship because the moles are equal. So these moles are not equal. These are not equal. You understand? So that's why dilution is an easy problem because the formula is reduced to just what? M1 V1 equals M2 V2. That's why we're able to use this equation. Yes? Okay. So look at the problem. Calculate the molarity of the solution made by diluting 0.050 liters of 0.1 molar HCl solution to a volume of 1 liter. Now the question is, what's M1? And what is M2? What is given, what is added? That's the question. So if you read the problem, it says calculate the molarity of the solution made by diluting 0.050 and 0.1. Those are your initials, correct? So M1 is 0.1 and V1 is 0.050 liters. Do you agree? Those are your initials. Your final volume is 1 point, so that is V2. Got it? So what is it that we're trying to find? M2. M2 is the question mark. Got it? So you come up with a set formula of M1 V1 equals M2 V2, and you're solving for M2. Can you try it, please? Can you substitute and solve? So what did you all get?
Any questions?
So probably what you have is understanding what the issues are and what time is. Understanding what the issues that they're trying to define. That's the challenge of the problem. So the minute it's a definition, you can use the formula and unequal equals continuity. So if you look at that, that's policy, and then, okay, so let's quickly take that complete. The other good news is that your volume does not have to be in here, or you're going to do what? You know what? We have a V1 here and a V2 here, right? We have both in here to the 30 units. So long as it's both in the same unit. So if you have on this line, that's it, down here. And so long as you keep them both in the same unit, you're good. Got it? So try problem 6.8.
It's like the same thing, but like different formulas.
M1 V1 equals M2 V2. Yes? So what is your M1? What are you trying to find? What are we trying to find?
And this is
V2. So what's M1 then? 0.400. What's V1? 50 milliliters. What's M2? 0.0? Oh, 0.200. Ooh. And therefore, V2 is X. Did everybody get that, please? V2 is now X. So solve for X, right? So we start with a new page here, and we say M1 V1 equals M2 V2. Yes? So I divide both sides by M2, right? That's one way to look at it. Or you could multiply, as in, you take M2 to the other side. Yes? So the formula is going to be M1 V1 divided by M2 is equal to V2. Everybody got that, please? And now solve for V2. What did you get, Rebecca? 100 mils? Any questions? So it doesn't have to be difficult, yeah? Now I'd like us to focus on